There's one more new idea that we're going to talk about in this fifth video for chapter 4. And then we're going to put everything together to get a clear picture of what we're seeing. The last idea to discuss is the coefficient of determination, or R squared. Remember, R is the correlation coefficient. If you take R and square it, that's going to be your coefficient of determination. The coefficient of determination is a measure of how well the regression line summarizes our data. Specifically, and what you need to know for this class is it tells us the percentage of variation in the response variable y that is explained by the explanatory variable x. Your calculator can calculate this, as we'll see in a bit. You can also calculate it if you have R. Just a couple of examples before we do an overview. If R equals 1, the coefficient of determination is 100%, because 1 squared, 1 times 1 is 1, and 1 as a percentage is 100%. So we would say 100% of the variation in y, that vertical movement in y up or down, is explained by the x, the explanatory variable. Let's say R equal to 0.8. Well, 0.8 squared, 0.8 times 0.8 is 0.64, or 64%. So we could say the coefficient of determination is 64%, and 64% of the variation in y is explained by x. It's always a percentage of the variation in y that's explained by x. Next, let's put everything together in one big example, an overview of what we've discussed so far in chapter 4. Here I have a data set consisting of the number of statistics classes missed by 7 students, as well as the number of questions they got correct on their final exam. So I have a student who missed 4 classes. He or she got 35 correct on the final. Student who missed 6 classes, they got 32 correct, pretty good. Up until I've got students who missed 20 classes and 30 classes. They didn't do very well. They only got 13 and 8 respectively correct on that final exam. The first thing I want to know, well, is this data set linear? So I need to get my data into the calculator. Go to stat edit. So I'll put those number of missed classes in L1, just going down the list. And I'll put the number of correct final exam questions in L2. To see if it's linear, remember that you can hit the zoom button and the number 9. So this looks to be fairly linear. It's not a perfect line, but I can sort of see a line going through this data. It's close enough to say, yeah, it's linear. So I'll say yes here. I can find my R on my calculator if I hit the stat button, go over to calc, select number 8, the linear regression in the form a plus bx, and I see my R is a negative 0.98 if I round it to 2 places. To interpret this R, well, what does this R tells me? What does the R tell me? It tells me that I have a strong relationship, and also I have a negative trend. So this is strong and negative relationship or trend between this data. There's a strong relationship between the number of classes you miss and the number of questions you get correct on the final exam. My R squared, something we just discussed up at the top, 0.96, that is 96%. So I could say 96% of the variation in my Y, which is the number of final exam questions correct, and is explained by my X, which in this case is the number of missed classes. It's the percentage of variation in Y that's explained by X. My regression line has the form Y equals A plus BX. Y equals A, which is 37.7 according to my calculator, minus 1.1x if I round that B to one decimal place. The interpretation of A, that's the 37.7, that's my y-intercept. That's my prediction when x is 0. So we can say we predict 37.7 correct questions for a student who misses 0 classes. For my B, the negative 1.1, that's our slope. That's how much we predict the y to increase, or in this case, decrease by, as the x goes up by 1. So we can say as the x, or as the number of missed classes increases by 1, the number of correct final exam questions decreases by 1.1. So pretty much for every class you miss, you're going to miss one more final exam question. You're missing important information from that class meeting, so it's important to attend class. The final two, we make a couple predictions. First off, when x equals 9 for somebody who misses 9 classes. So I'll just plug 9 into my regression line equation. 37.7 subtract 1.1 times 9 gives me 27.8. I would predict someone who misses 9 classes will get 27.8 questions correct on the final. That would be the average. Not a guarantee, but that's what we predict. Same idea for 37. I'll say 37.7 minus 1.1 times 37. That gives me a negative 3. And I'm going to note that this would be an extrapolation. My prediction is that somebody who misses 37 classes will get negative 3 questions correct. Well, you can't really get negative 3 questions correct. The lowest you could get would be 0. So this doesn't really make sense. And note my x values only went from 4 to 30. So anything past 30, like 37, would be an extrapolation. And this covers just about everything we've seen so far in Chapter 4, putting it all together with an example.